Today we're going to learn about how to measure the concentration of a solution. This is section 4.5 in your book. And we have a term called molarity. And molarity is the unit that we use in chemistry for concentration. Molarity just represents the concentration of something. And concentration is, if you think of the word concentrated, like concentrated orange juice, it means you have that stuff you have from the freezer, and it's super concentrated, and you dilute it down into your orange juice that you're going to drink. So you have a very high concentration of orange juice. It's called orange juice concentrate when you buy the stuff from the freezer section. So in chemistry, we use molarity, and the symbol for the molarity is M, capital M. And when we see a capital M, we read the M as molar. We'll see in some problems later on, you'll hear me use the word molar. And the equation for molarity is moles of solute per liter of solution. And the solute is the chemical that's dissolved in the water solution. We will be dealing only with aqueous solutions in this class. So the solution is always a water solution. And symbolically, molarity is moles over liters. Moles is N, V is liters, or volume. So let's do a problem. In this first problem, we want to know what's the molarity of a solution containing 10 grams of NaOH in 100 milliliters of solution. So we have to think about this 10 grams here and the 100 milliliters. Noting that the 10 grams we can convert to moles. And right here, this milliliters, hopefully you recognize that that's a volume. So we're going to use the equation. Molarity is N over V. We need to find moles. So we have 10 grams of NaOH. And how do we get from grams to moles? We use grams to moles use molar mass. And the molar mass of sodium hydroxide is 40 grams to 1 mole. Why did I put the grams on the bottom? So that we could cancel out our units. We have to cancel our grams. Okay, so this is 0.250 moles of NaOH. Notice I kept 3 significant figures here. I put that last 0 there to signify that we have 3 sig figs in this problem. Now we need to find our liters. Find V. We have 100 milliliters of solution. And hopefully you all know that there are 1,000 milliliters in 1 liter. And that would come out to 0.100 liters. Why did I put those zeros there? Why are these zeros important? Sig figs. I started with 3, and I want to keep 3 right here. So now we can just plug into our equation. M is N over V. And we found our moles up here, 0.25 moles, and 0.100 liters. That comes out to 2.5, that is right, 2.50 molar. We put a capital M. We don't write moles per liter anymore. We put in a capital M for moles per liter. And then we write the chemical that we're talking about. So this would be a 2.5 molar sodium hydroxide solution. That's a pretty concentrated sodium hydroxide solution, actually. Okay, another problem. What mass of magnesium chloride is in 250 milliliters of a 0.100 molar magnesium chloride solution? So right here, I've got my molarity. Right here, hopefully you recognize this as a volume. And I'm trying to get mass. Mass will be grams. And in order to get my grams, I first have to find my moles. to replace my molar with moles per liter. Because remember, the molar is moles per liter. So we're going to replace, wherever you see a molar, we'll rewrite it as moles per liter. And hopefully you'll recognize that when you have moles per liter, if you multiply this unit, this set of units by liters, you're left with moles. But I have a little problem over here. This is in milliliters. To go from milliliters to liters, I need to divide by 1,000. Right? Hopefully you're getting that. You have to get used to going from milliliters to liters. So I have to divide this by 1,000 to get liters. So that would be 0.250 liters. I have to make sure that my units cancel correctly. I cannot just plug in milliliters and hope that it'll cancel. So now, the number of moles is going to be 0.025. How many sig figs should I keep? Let's see, this is 3 and 3. I need to keep 3. This right here is only 2 so far, so I have to put a 0 in here. 0.250 moles of MgCl2, and I'm noticing I'm missing an M right there. MgCl2. Okay, so I've got my 0.0250 moles of MgCl2. I'm not done yet. I was asked for mass, so I now have to convert my 0.0250 moles of magnesium chloride to grams. So we're going to need the molar mass. 1 mole of magnesium chloride. So when we calculate our molar mass, we get 95.21 grams of MgCl2 per mole. And the moles of MgCl2 cancel. And I get that this is equal to 2.38 grams MgCl2. And I'm done. Now, one of the hard parts in this problem is when you're solving for liters. A lot of students, this equation right here, they tend to write the equation incorrectly. So if we were to solve this equation for liters, we get M times V is N, and V is moles over molarity. A lot of students flip that upside down, so you just have to be careful when you're doing those problems. All right. Okay, in the same section, we also have the concept of diluting a solution. Often in chemistry, we have what are called stock solutions. We keep them in the chemical supply room, and we will dilute those stock solutions. They're what we have on stock, like what you have on stock at the grocery store. So it's not a special word. It's just like the stock at the grocery store, stock in the chemistry supply room. So we take our stock chemicals, and then we dilute them down because we don't want to keep all the different concentrations that we might want for different labs. So let's look at what we do when we have a dilution problem. And I need to dilute something from my lab in the supply room, and I need it for a lab at a lower concentration, so I'll dilute my stock solution. The equation for diluting solutions is right here. Our initial molarity times our initial volume is our final molarity times our final volume, where 1 is initial, 2 is final. Another way that this is written and how students memorize this is MIV equals MFVF, where I is initial and F is final. And you might hear some of the students in different chemistry classes walking around saying MIV is MFF. Oh, is that MIV is MFF? So that's just the dilution equation. Let's do a problem. What's the final molarity if 25 milliliters of 0.1 molar sodium hydroxide stock solution is diluted to 100 milliliters? So let's first identify all of our variables. I start with this. This is my initial volume. Right here is my initial, molarity. And we dilute this to a final volume of 100 milliliters. And I'm trying to find M final. So I'm going to solve this equation for M final. The final molarity is MV over VIF, V final. Now I'll just plug everything in. Because my volumes are in the same units, I do not need to convert them into liters this time. So I just substitute in my initial molarity, 0.1 molar, initial volume, 25 milliliters, final volume, 100 milliliters. The milliliters cancel, and I get 0.025 molar NaOH. So that would be my final volume after I dilute down my initial volume by a factor of 4. Okay, so another problem. Describe how to prepare a 250 milliliter, hold on, I just read that wrong, sorry. Describe how to prepare 250 milliliters of a 0.1 molar hydrochloric acid solution from a 0.5 molar hydrochloric acid stock solution. So, first let's identify what we have. We want to prepare 250 milliliters of a 0.1 molar hydrochloric acid solution. So is that where I'm starting or where I'm ending? Hopefully you realize these two things that I've circled, that's my final condition. That's what I want to prepare, and that's what I end up with. This is my final molarity, my final volume. And over here, this must be my initial molarity. It's clearly a molarity, and the only other molarity I could use is an initial. So I must be trying to find the only missing piece, which would be the initial volume. And we'll solve our MIV-ISMA-FIF equation for the initial volume, MF/VF over MI, and plug in our values. Notice molarities, the units will cancel, and I'll be able to report my final answer in milliliters. Let's see, my final molarity was 0.100 molar. That's what I'm trying to prepare. My final volume is 250 milliliters. And my initial molarity, 0.500 molar. Okay. And this is equal to 50.0 milliliters. Notice I kept 3 significant figures because I started with 3 sig figs in all my numbers in the question. Now let's see, I have to answer the question. Describe how to prepare this solution. Now, my stock solution, I've just figured out I need 50 milliliters of my stock solution. So I'm going to measure 50 milliliters of stock solution, and I need to end up with 250 milliliters total. So I have to think about, well, what do I do? I started with my 50, I have to get to 250. I hopefully realized I need to add 200 milliliters. Because I need to get to 250, I started with my 50. So I need to add 200 milliliters, and we add distilled water. To the solution. And that's the complete answer to that problem.